Hey guys, here is section 6.3 day 1 continued. In the other video, I went over with you guys what the period of each trig function is. That each trig function is going to start repeating outputs after so many inputs go in. So we saw that the cosine, sine, cosecant, and secant all have a period of 2 pi radians. It takes one complete rotation for their outputs to start to repeat. But then we saw that the tangent and the cotangent functions have a period of pi radians. It takes only pi radians, or half of a rotation, in order for those outputs or those ratios to start to repeat. Okay? All right, so we're still working with trig on the coordinate plane. So by taking trig to the coordinate plane, we have been able to take an angle of any size, right? I can take and make angles of any size now, angles of rotation, and you can relate that angle to a point on a circle. And then you can create a right triangle, and now that right triangle has a side length of x, a side length of y, and a hypotenuse, which is the radius, and on the unit circle, that radius is 1. All right, and then we have redefined the trig ratio using x coordinates, y coordinates, and the radius of that circle. All right, so just to make a little bit of a side note, I just want you guys to remember that the tangent function by definition started as the sine function divided by the cosine function. And then his reciprocal cotangent by definition is the cosine of angle theta divided by the sine of angle theta. Okay, hold on to those ones. You probably need those ones for day 2 notes. All right, okay, so working with these trig functions and all of their properties, so their domains and ranges and periods and all of their behavior, you have to remember how these trig functions work. Trig functions are functions of an angle. That means they depend on an angle. So that means a theta or an angle goes into the trig function, and then a ratio of 2 side lengths comes out, right? So that's how they work. You plug in an angle, and it spits out a ratio. So an angle goes in, and a ratio comes out. So when you start being asked what are their domains and ranges, well, remember, their domain is going to be who are you allowed to plug in? What angles are you allowed to plug into that trig function? And then their ranges are going to be their y values. Their y values are going to be ratios. So the range is going to be what ratios come out of each trig function. Okay? All right, let's do the sine and cosine first because they're probably the easiest. Well, remember, now that we have redefined the trig functions on the unit circle, all of the x and y coordinates that live on the unit circle are the cosines and sines of all those angles. So remember, when you're looking at this unit circle, all of these x coordinates represent the cosines of all of these angles. All of these y coordinates represent the sines of all of these angles. So guys, when I ask you, what is the domain of the sine and cosine function? I'm asking you, what kind of angles are you allowed to plug into this function? Well, guys, look at the unit circle. I can plug any one of these angles in and keep rotating around and around and around. I can rotate this way and plug angles in, and all of the x and y coordinates are going to be some definable ratio. So that means you can plug any angle you want into the sine or cosine function, and you're going to get some definable ratio out. So their domain is all real numbers. Plug any angle you want in, and nothing bad will happen. All real numbers, all real angles. And especially now that we measure angles in radians, that's a real number. Okay, what is their range? Well, their range is a little bit different. Well, again, if you look at the unit circle, which is telling you all the cosines and sines of all of these angles, so all of these x and y coordinates represent their sines and cosines. Well, guys, look. Their cosine ratios are the x coordinates, which all fall in between -1 and 1. All the x coordinates fall in between -1 and 1. All of the y coordinates that represent all the sines of these angles all fall in between -1 and 1. So that means that all of the ratios for any angle, as far as sine and cosine are concerned, are going to be some ratio in between -1 and 1. But again, why is that? So if you look here, think about how each of these trig functions work. An angle goes into the sine function, and a ratio of O over H used to come out, but now a ratio of Y over R comes out. And then the cosine function, an angle goes into him, and a ratio of A over H used to come out, but now we've redefined that to be an x coordinate over a radius. Well, guys, picture a right triangle, right? You have an angle, you have O, A, H. If I asked you what's the sine of angle theta, you would say it's O over H. Well, guys, H is always the biggest side of the right triangle. So that means your ratio is always a small number divided by a bigger number. Well, what's a small number divided by a bigger number always going to be? Less than 1. It's going to be some number smaller than 1, like point something, right? Even if you look at your circle, your radius is your hypotenuse. So the radius is always going to be bigger than an x-coordinate or a y-coordinate, just by how the sides of a right triangle work. So that means the y-coordinate is always going to be a smaller number than the radius. So it's going to be a small number divided by a bigger number. What's that always going to be? A number less than 1. And now again, if you think about it, if one of these numbers is negative, then a small number divided by a big number, when it's a negative number, will have to be bigger than -1, because that's where they fall. Numbers like that, they'll be bigger than -1. So that means that all of the sine ratios, all of them fall in between 1 and -1. So that's his range. The ratios that come out of the sine function are numbers in between -1 and 1. Cosine works the exact same way. A over H, X over R, A's always going to be a smaller number than the hypotenuse. So it's always going to be a small number divided by a big number, which is going to be a number less than 1, or a number bigger than -1 if it's a negative number. Same thing, the x-coordinate is always going to be a smaller number than the radius. So that's always going to result in a number less than 1 or bigger than -1. So the range of the sine and cosine function is -1 to 1. And you can see all the x and y values that live on this circle are from -1 to 1, or -1 to 1. So the ratios that come out of a sine or cosine function are going to be numbers in between -1 and 1. All right, let's do the domain and secant, the domain of the tangent and the secant functions. Well, first, let's see how they work. If I ask you what their domain is, I'm asking you what angles are you allowed to plug into these functions? Well, the tangent of angle theta is now defined as, it used to be O over A, right? But now it's a y-coordinate over an x-coordinate. The secant of angle theta, it used to be H over A, because he's the reciprocal of cosine. But now he's an a radius divided by an x-coordinate. So guys, think about it. In these cases, if the x-coordinate is equal to 0, then what are the ratio going to be? So if I have an x-coordinate of 0, what's the ratio going to be? It's going to be division by 0, which means it's going to be undefined. So angles who land at a point where the x-coordinate is 0 are not in the domain of the tangent and secant function. So guys, what angles have an x-coordinate of 0? Well, let's look. What has an x-coordinate of 0? X-coordinate of 0, no. You can even look here. X-coordinates of 0. Nope, 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 nope. Right here, 90 degrees has an x-coordinate of 0. 90 degrees, which is pi over 2 radians. Okay, let's go back. What other angles have an x-coordinate of 0? No, 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 no. Yes, 270 degrees has an x-coordinate of 0. 270 degrees is 3 pi over 2. It's 3 90-degree angles, right? Okay. Let's keep going. So x-coordinates of 0, no, 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 no. So we've made one rotation. So now all the angles that land in the same spot as 90 and 270, all the angles that land in the same spot as 90 and 270 are also going to have an x-coordinate of 0, which means those are angles that you're not allowed to plug in. And I can even go this way. -90 is bad. -270 is bad. So that means if I keep going, this was 1 pi over 2, right? This was 3 pi over 2. This is going to be 5 pi over 2. That's 450 degrees. He's bad. Okay? This is going to be, that's 5 pi over 2. That's my 7th 90 degree. That's 7 pi over 2. That's 630 degrees. So these are all angles that if you plug them into the tangent or secant function, you're going to create this ratio of y over x or r over x, which means you're dividing by 0. And that means that these angles are going to make an undefined ratio come out. Again, if I asked you what's the tangent at 90 degrees, that's y over x. That's 1 over 0. That's an undefined ratio. If I asked you what's the tangent at 270 degrees, y over x, that's negative 1 over 0. That's an undefined ratio. So these are all angles that you cannot plug in to the tangent and secant function because their ratios require you to divide by an x coordinate. And these are all angles that live at a point where the x coordinate is 0. So when we go to write it out, what are the domain? It's any angle except these angles, the angles that have an x coordinate of 0. So if you look here, because we talk about our domains and ranges in radians, so that's 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. They say that theta cannot be an odd integer multiple of pi over 2. Odd integer multiples of pi over 2. So those are all angles that you are not allowed to plug into the tangent and secant function. You will have an asymptote. You will have an undefined ratio that comes out for any of these angles. So we say their domain is theta can be any real number except it cannot equal, starting with the first bad one, and really it's positive or negative. We start with pi over 2, and then plus or minus. Well, how many radians away is if 90's bad? How many degrees away is the next one? 180 degrees gets you your next bad angle. So that's a period, or I should say an amount of pi radians. So that means pi radians away from him, there's a bad angle. The next bad angle is pi radians away from him. The next bad angle is pi radians away from him. And we can go this way. Pi radians this way in a negative sense as well. So we can say theta cannot be pi over 2 plus or minus pi radians away from him times k revolutions. 1 revolution, 2 revolutions, 3 revolutions, okay? So that's how you write their domain. Any angle except starting at pi over 2, 90 degrees, and then 180 degrees away from him are all bad angles. And that's how you write its domain, okay? So again, theta cannot be an odd integer multiple of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. These are all bad angles for those trig functions. All right, well, what is the range? Let's do their range. I'm going to do their range separately. Well, what's the range of the tangent function? What ratios come out of the tangent function? Well, think about how the tangent function works. An angle goes into him, but not these angles. An angle goes into him, and what ratio comes out? It used to be O over A, but now it's a y coordinate over an x coordinate. Well, guys, the one thing you got to like about that is the O and the A, the opposite and the adjacent side, or the y coordinate and the x coordinate, there's no rhyme or reason to who's bigger. O could be bigger, A could be bigger, Y could be bigger, X could be bigger. So you could be taking a big number divided by a small number, or a small number divided by a big number. There's no rhyme or reason to who has to be bigger, like the hypotenuse has to be the biggest side. So in this case, really, it could be any number depending on if O or A or Y or X is bigger. So his range is all real numbers, all real ratios. Okay. Well, what's the range of the secant function? Well, how does the secant function work? Well, the secant function is the reciprocal of cosine, right? So it used to be h over a, hypotenuse over a. But now we've redefined him to be a radius divided by x. Well, guys, think about this. The hypotenuse is always the longest side. That's always the biggest number. So when you find his ratio, it will always be a big number divided by a smaller number. Well, what's a big number divided by a small number always going to be? It's always going to be something bigger than 1, right? If you take a big number and divide it by a small number, it's always going to be bigger than 1. Or if you're thinking about this in a negative sense, it's always less than -1. It's always past -1. And that's how the secant function is going to work. His ratios are always going to be a big number or a bigger number divided by a smaller number. So it's always going to create a ratio that's either bigger than 1 or less than -1. So I'm going to say y is always greater than 1 or y is less than -1. That ratio is always a number bigger than 1 or less than -1. So his range in interval notation would be -infinity to -1. I guess I should be including them. No, I do not. Union 1 to infinity. Okay? Perfect. Well, let's do the domain of the cotangent and cosecant function. What angles are you allowed to plug into the cotangent and cosecant functions? Okay, well, let's think about how their ratios work, how these functions work. An angle goes in, and what ratio comes out? Well, again, it used to be the reciprocal of tangent, so it's A over O, but we've redefined it to be X over Y. All right, and then the cosecant, it used to be H over O, right? The reciprocal of sine, but we redefined it to be a radius over a y coordinate. So now, if you're going to make a cotangent, let me get on the screen. If you're going to make a cotangent ratio or a cosecant ratio, you have to divide by a y coordinate. So think about it. Any angle that has a y coordinate that is 0, that's going to create an undefined ratio. So if the y coordinate equals 0, then the ratios are going to be something divided by 0, something divided by 0, undefined. All right, so angles who land at a point where the y coordinate is 0 are not in the domain of the cotangent or cosecant function, because those angles are going to create undefined ratios when you put the y coordinate on the bottom of the ratio. So what angles are those? Well, let's look. What angles have a y coordinate of 0? So who has a y coordinate of 0? Well, right here, 0 does. He's got a y coordinate of 0. That means that the cotangent or the cosecant of 0 degrees is going to be an undefined ratio. It's going to be x over y or a radius over y. That's not okay. That's an undefined ratio. So 0 degrees is the first bad angle. So 0 degrees or 0 radians is not in the domain of these two trig functions. Well, who else has a y coordinate of 0? No, 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 no. Yes, 180 degrees has a y coordinate of 0, which means the cotangent of 0 degrees is an undefined ratio. The cosecant of 180 degrees is an undefined ratio. So 180 degrees is out. He's not in the domain. And that's also known as pi radians. All right, so pi radians is out. What other angles have a y coordinate of 0? Let's see. No, 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 no. No, 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 yes. So now I'm back at 360 degrees is also bad. So 360 degrees is bad. Well, that's 2 pi radians, right? Well, again, now any angle that lands in the same spot as 0 and 180 and 360, they're all bad. So if I'm at 360 and I go around another 180 degrees, what is that? 540 degrees, that's out. 540 degrees is 3 pi radians, okay? So 3 pi radians is out. If I go around again, starting, I'm at 540, I go another 180 degrees, now I'm back there at a y coordinate of 0, he's out. 720 degrees is out. Well, 720 degrees is 2 complete rotations, so that's 2 pi and 4 pi. 4 pi is out. Okay, so we say all of these angles are not in the domain of the cotangent and cosecant function because they will create undefined ratios because they all live at a point that has a y coordinate of 0. So that means that theta cannot be, if you notice, 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. Theta cannot be integer multiples of pi. Okay, so now it cannot be intermultiples pi, so go back. So now we're going to say the domain is theta cannot be in angle. Well, if you notice, the first bad angle for these functions was at 0 radians or 0 degrees. So theta cannot be 0 radians plus or minus. Each angle lived 180 degrees. 0 was bad, 180 was bad, 360 was bad, 540 was bad, 720. So every 180 degrees, a bad angle occurred. Or every pi radians, a bad angle occurred. So we say theta cannot be 0 radians plus or minus pi radians away from him times k revolutions. 1 revolution, 2 revolutions, 3 revolutions, and so on. So theta cannot be 0 radians plus or minus pi times k revolutions, okay? Awesome. All right, I'm going to start another video to do the back of the notes. I'll be back.